now what you're writing is about these things called excess reactants. Well, excess reactants are the total opposite of the limiting reactant. If something's in excess, what does that mean? Just a normal everyday life. You have too much of it, right? If I have excess of something, there's plenty of it. I'm never going to run out of it. For example, some of you may say, I have an excess amount of dry erase markers because I have a bit of an obsession with dry erase markers. Okay? I might have an excess of pens because I have like 100 pens on my desk. I have an excess of water jugs back there. Okay? Excess means I have plenty of it. It's the thing I have more of. Okay? On the flip side is the thing that we really care about. The guy that we're going to spend the most time talking about. His name is the limiting reactant. The limiting reactant is the thing that I am going to run out of first. It's the thing that limits how much product that I can make in a chemical reaction. Nothing that I do today there's nothing that I'm going to do today that you haven't seen before. These problems are longer. But they are the exact same things that we did on Friday. When I say the exact same things, I mean like the exact same things. You just need to trust me. We talked about what a theoretical yield was last week. We talked about how a theoretical yield was just the answer to any stoichiometry problem. That doesn't change today. But a theoretical yield in a limiting reactant stoichiometry problem is always the smallest number. Make sure you make a note of that. The smallest number will always be the theoretical yield, and that's going to be the guy that tells you the limiting reactant. If I make this, no pop quiz. No, I really didn't. That was a really bad shot. I made it that time.
The end is really right there.
Sorry, I just have to take a 10 minutes. Can I move on? Boo. You're supposed to be scared. Reagan, you good?
I leave Friday, so whatever
Okay.
you can fit in your schedule, I can understand.
Hey, let's watch the video.
What the temperature is on Thursday. It's supposed to be so warm. Oh, it's gonna be 48. We're not going for a walk.
Bruh. Alright,
You bring your Rice Krispies back.
switch back to the MacBook.
Shakira.
So, I want you to pay attention to this video that I'm about to make you watch. If my Apple TV connects. You guys can't watch this because of copyright, but bye.
To report back.
Okay.
That was a good one, Claire.
Okay, anyways. In chemistry, I want you to look at how this would look with stoichiometry. Let's look at number 1. You do not need to write the full problem down, just write the reaction. Adia, put it away or it's mine.
Ow.
In this reaction, I want you to pay attention to what's being given to you. Because this is going to look a little different than the problems that we did on Friday. Somebody tell me what's different than what we were doing on Friday. What new piece of information have I given you here?
2 different numbers.
We have 2 different givens. I even balanced the equation for you because I was feeling generous.
Oh, thank you.
I did not balance it on your homework. So we have silicon dioxide reacts with carbon to produce silicone and carbon monoxide. Natalie, what am I solving for here? What's my unknown going to be?
How many moles of CO?
Perfect. So we're looking for moles of CO. Gage, show me one of my givens.
SiO2 4.5
SiO2, we have 4.5 what?
moles.
Moles. Ethan, what's my last given?
3.5 moles of carbon.
Perfect. The new pieces of information. Now I have a number for both of my givens, which is not something we've yet done. But I promise you, nothing we do today will be different than what we did on Friday. Here's what I need us to do. I need us to be able to look here and tell us which one of these is going to run out first. Hey, just looking at it, which one do you think is going to run out first?
3.5 moles of carbon.
Lucia thinks 3.5 moles.
Sorry.
Bruh. Of carbon's going to run out first. Who agrees with her? Who disagrees? Okay, I guess Ethan was.
I just can't.
Huh? Because by the end of this lesson, I'm going to prove to you that you can't just look at those numbers and tell me which one's going to run out first. You'll see why.
But
Here's what I need us to do. I need us to find out the theoretical yield, the limiting reactant, and the excess reactant. Those 3 things. We should be able to tell from doing this. Hey, the first thing I'm going to do is just do my normal grid. Pick a reactant, and we're going to do a grid. I'm just going to pick this guy first because he's the one on the left. Is that okay?
no.
We always start our grids with our given. In our case, this guy is going to be 4.5 moles of SiO2. Hey Claire, if I have moles of SiO2 right here, what's my unit going to be down here?
SiO2
What about SiO2? Moles, grams, or molecules?
moles.
Moles, perfect. So we'll have moles of SiO2 down here. Hey, I have moles on the bottom, which means what am I going to put on the top here?
Moles.
Moles of what?
Your unknown.
Moles of the unknown. So we'll have moles of carbon monoxide. Hey, I have a moles over moles. Where do I get numbers for this step? Coefficient, so we'll have a 2 over a 1. Does everybody agree with me? Hey, is this the end of the grid or do I need to keep going?
No, you're good.
We're good, right? We're looking for moles of CO. We're at moles
But
of
what
CO.
about your 3.5?
We'll get there. Hey, run your grid. What's 4.5 times 2?
9.
9. So this guy will produce 9 moles of carbon monoxide. Hey, now we need to do that exact same thing, but with this guy. So now we're going to have 3.5 moles in a new grid, carbon. Hey, if I have moles of carbon here, what am I going to have down here?
You're given.
Moles of carbon. Hey, what's going to go above moles of carbon?
CO. Moles.
Moles of CO. I have moles over moles. Where do I get my numbers?
2 and 2 college.
The mole to mole ratio. Hey, I want you to notice this. Look, these are two different grids with two starting amounts, right? But once we flip to our unknown, it looks the same. We have 2 moles of CO here, 2 moles of CO there. Do you agree?
Yeah, but you have a 2 on the bottom, so that changes it.
But that's an unknown, or that's a no, sorry. It's only the same for your unknown stuff. It's easier to look at when we have a bigger problem, but trust me.
Wouldn't it come out to different answers though?
Your answer will be different, yeah. But just the actual look of the grid, 2 moles of CO, 2 moles of CO. So once you get to where you're starting to look at the stuff for the unknown, it'll look the same. Hey, 3.5 times 2 divided by 2, what do you get?
3.5.
I asked which one did you think was going to run out first. In this case, Lucia was right. The 3.5 moles of carbon would run out first because it turns out 3.5 moles of carbon, well, that will make 3.5 moles of carbon monoxide.
So would that be your limiting reactant?
This will be my limiting reactant. Now, chemists are lazy, so I'm okay with you guys abbreviating limiting reactant as LR. If you want. Hey, what would my excess reactant be?
Here, just one.
The silicon dioxide, right? Because he produced way more than the other guy. And you can abbreviate excess reactant as ER. Hey, what would my theoretical yield be?
Average them or something. Do you just put a comma because
What's
you're limiting.
what's the limiting reactant? This guy,
it's
right?
it's the most you can get out.
The limiting reactant, he's gonna run out first. So when he runs out, well, how much stuff will you have made when he runs out?
3.5.
This is the theoretical yield. That you cannot abbreviate, sorry.
So is your theoretical yield always your limiting reactant?
Yes, your theoretical yield will always match up with your limiting reactant. Because given 3.5 moles of carbon and 4.5 moles of silicon dioxide, if I went to the lab, the absolute theoretical most amount of carbon monoxide I can make would be 3.5 moles of carbon monoxide. Because I'll run out of this guy, and if I run out of that, well, I can't do the reaction. Does that make sense? How do we feel so far?
I don't.
I told you, this stuff is not any different than what we did on Friday. We're just adding some vocabulary words, and we have 2 grids for each problem now. Hey, let's look at numero dos, por favor. You're so close to spring break. You should make it, I believe. Well, that's something fun.
Maybe they sell it like clothes.
As would be there, doors to do this close, which is, I thought it was like close beforehand.
That's a lot.
From 6 thirty. Pretty close.
How many grams of carbon dioxide are produced?
Too close to graduation.
How many grams of carbon dioxide are produced when 238.7 grams of C5H12 reacts with 294.6 grams of O2? What is the limiting reactant in this reaction? AD, what do I always start with no matter what?
Given
Before I even do my givens?
balancing.
Balanced equation. Hey, is my equation balanced? Yeah, it is. I balanced it for you. You're welcome. I'm the best. Hannah, what's my unknown here? What am I solving for?
Grams of CO2.
Perfect. Reagan Clark, what's one of my givens?
238.7 grams of carbon by H12.
Perfect. Reagan Ferris, what's my other given?
294.6 grams of oxygen.
Perfect. Emery, which one do you think, looking at these numbers, is going to be the limiting reactant?
I don't know. C5H12.
Why?
It looks smaller.
It looks smaller, right? Natalie, what do you think?
About what?
Which one of these do you think is going to be the limiting reactant? Which one do you think will run out first? Why?
It's 238.
We have less of it, right?
Yeah.
I feel like it's gonna.
Reagan, what do you think? Which one do you think is going to run out first?
Oxygen.
You think oxygen?
Yeah.
Why?
I don't know.
Just a gut feeling?
Yeah.
Grace, what do you think?
Um,
Pitt, which one do you think?
C5H12.
Why?
Well, now I don't think it is, but it has less of it.
That's less than. Hey, let's work our grids and see what happens. Hey, I'm gonna start my grid the same way I did before, right? Always start with my given. In this case, I'm gonna start with 238.7 grams of C5H12. Vivian, if I have grams of C5H12 here, what am I gonna have down here? Perfect. Hey, every time I see grams in my grid, what do I need to find? Molar mass. I need molar mass. Every time we see grams in my grid, I need molar mass. Think GGMM. Grams in grid, molar mass. The molar mass for C5H12, has anybody calculated that already? Did somebody say yes, or did nobody do it?
I got 72.146.
Perfect. Molar mass for C5H12, 72.146. Is that what everybody got? Hey, what's going to go on top of that? We're saying for every 72.146 grams of C5H12 is what?
1 mole.
1 mole. Am I done or do I need to keep going? Am I done or do I need to keep going? I need to keep going, right? We're at moles. I need to get to grams. Hey, if I have moles of C5H12 here, Ethan, what am I going to have down here? If I have mole of C5H12 here, what's going to go down here? What unit?
1 mole.
Ignore, drop. Why 1 mole? Where's the 1 coming from? Huh? Moles of C5H12. Just copy the unit. It's a diagonal drag of the unit. So if I have moles of C5H12 here, I can go diagonal. It's going to be the same thing. Does that make sense? Hey, if I have moles of C5H12, what's going to go on top of that? According to your roadmap, Moles of the unknown. So we'll have mole of CO2. I have moles over moles. Where do I get those numbers? It's our special step. Coefficients, the best step in the book. We'll have a 5 and a 1. Am I done or do I keep going?
Youth programs.
Have to go to grams. Lucia, if I have moles of CO2 here, what's going to go down here?
Moles.
Moles of what?
Moles of CO2.
Okay. Natalie, what's going to go above that? What unit is going to go up here?
Is it the mole of the unknown?
We've got moles of unknown here. What's going to go here, though?
C5H12? No. I don't know.
Look at your roadmap. Where are we at in our roadmap?
So molar mass.
We need the molar mass of CO2.
Is it the molar mass grams though, technically?
I didn't need to write the word molar mass. Yes, it is grams. 12 plus 36. We're at 48.01. Or no. 36 plus. Nope, 32 plus 44.01. Is that what everybody got for their molar mass for CO2? Sorry, mental math was not mathing. 44.01. Hey, type down your calculator. Tell me what you get.
Wait, what about the moles from the body? You don't multiply it by 5? Why don't we multiply it by 5?
What? I meant
The other one? Good calculator.
What'd you get? What'd you get? What'd you get? I disagree.
No, Natalie's we're calculating.
What?
We're calculating.
We're running the grid. The grid's filled in. Now we're multiplying everything across the top, divide by the bottom.
I thought we were just looking for the grams. I'm sorry.
What did we get, people? Perfect. 728.05. Yep. Hey, what do I need to do next? I need to do the same grid, but for the other reactant. So we have 294.6 grams of O2. If I have grams of O2 here, I'll have grams of O2 down here at the bottom. Anytime I see grams, I know it's molar mass. 16 plus 16 is 32 grams. And that's for every 1 mole of oxygen according to your roadmap. If I have mole of O2 here, I'll have mole of O2 down here. Moles on the bottom, I'm immediately screaming mole to mole conversion, mole to mole conversion, mole to mole conversion.
But there's a mole on the bottom on the gray one.
What?
On the one above on the far right.
But this is the first time you see it.
So the first one's.
So we'll go to moles of CO2. Coefficients are 5 and 8. If I have moles of CO2 here, I'll have moles of CO2 there.
I wouldn't know.
Which will go to grams of CO2.
Who's calculating?
Hey, you guys see what I mean now? I said this before, but anything for your unknown, looks exactly the same in both grids.
Is that an S or a 5?
It's a 5.
Only on the top though, right? Oh wait, never mind. I see what you mean.
Any step that has your unknown involved looks the exact same in both grids. What changes is your known stuff, your givens. Hey, when you run this grid, somebody tell me what you got. When you run your grid, somebody tell me what you got when you typed it in your calculator.
I got 253.20.
That sounds right.
Did you have a little mistake?
Hey, so look at our grids here. Look at our answers. Most of you predicted that C5H12 would be the limiting reactant. But which one is really which one's the real limiting reactant? O2. Because look at the difference in what was produced. O2 only produced 253.23 grams of CO2. C5H12 produced 728. Which means O2 is my limiting reactant. What's my theoretical yield? Good, 253.23 is my theoretical yield.
Wait, what was the first thing you said before you said what's the theoretical yield?
What was the limiting reactant? What's the excess reactant?
It's a C5H12.
Good.
So do you always go out 2 decimals in your theoretical yield? Or do you just
As long as you have at least 3 sig figs, you'll be fine.
Hey, I have a question about sig figs.
What?
When you have a decimal like 0.168 or something like that, does 0 count as a sig fig?
No. Like this?
Yeah.
No. Leading zeros are never significant. Okay, do you need to do the third one or you?